Hi, welcome to online tutorial series on 8051 programming from JCBRO Labs. So in today's online session, we are going to talk about how to do program of this 8051, how to write 8051 program in embedded C language, and then we will be interfacing or we will be writing a program to interface LEDs with the help of 8051 microcontroller, and then we will be doing the simulation of the same on Proteus software. Okay, so let's wait if some of the people join, and then we will start it. Okay. Hi. So if you have joined, you can let us know by commenting your name or by putting your name in this live chat, and further we will also ask certain some questions based on our earlier tutorial videos, and whoever will give the correct answer, he or she will get a price of uh, 10 to 15 rupees range, and then the amount will be directly transferred to their account, right? Okay. Okay, so let's wait, and okay, let's start. So when we talk about programming of 8051 microcontroller, in our earlier four videos we have talked about like how to do programming in assembly language, but as you have seen, like writing a programming in assembly language is in itself a tedious task, and you have to remember a lot of the stuff, but that is very important programming if you have a system which is very critical in memory requirement. So in that case you go with this assembly language programming. Now in general case, everyone knows about like C language, so general tendency is to use embedded C programming to learn different concept or to the same thing. Okay, so Prince Sharma has joined. Okay. Hello Dimpy, hello Prince. Okay, now coming to the theory part of it, uh, we will be talking about embedded C. Okay, I just lost my connection with this tab. Let me connect it. Okay. So now, so we are going to talk about with embedded C. So embedded C is nothing new. It is regular C programming. The only thing is in this embedded C we have additional keywords, right, which are related to that particular microcontroller. So if we are talking about like 8051, so some of the additional keywords will be added here. For example, port can be accessed by P1, P2 and P3. Similarly, and different registers which we will be talking about in further as we move further in the programming, different registers like related to timers or USART, those register can be accessed directly, and that is why it is this particular programming is embedded C. And the compiler used for this embedded C is specifically designed for 8051 microcontroller. So it is not like you can write the program for any other microcontroller on the same compiler. Okay, so if the compiler is custom designed for a specific microcontroller, and that is why it is known as the embedded C. So let's try to write a small program in order to give you a brief, in order to give you a feel of it. Further, we are using the uh, mm, uh, Kill software for this purpose, and that is very famous for 8051 microcontrollers and ARM series of microcontrollers. Okay, so let's go to the kill. So we have seen kill for assembly language programming. It also supports writing program in embedded C as well, right? So as usual, we'll go to the project, right? And then we'll create a new micro project at the same location where we were creating all our projects earlier as well. We'll go to Dropbox live 8051, and then yeah, we'll create a folder for uh, mm, added C. So this is a folder which we have created, and within that we'll create a main project name. Okay, so demo, right? Then it will ask for the microcontroller. We can select atmel89c51. Okay, so let's go to atmel, and then you can choose anyone, 89c51 or 89s51 as well, and then okay, and yes. Okay, now we'll create our source file. So add new items to the source file, and we'll select C file here, and then main.c, and then we'll click here add. So this file has been added. Now we can go for target options. Here we can change the simulation frequency. So we'll be using this 12 megahertz. We have seen it because if we don't select the correct frequency while computing this delay, there will be a lot of problems there. Okay, we have selected this one, and then okay. So now these things are ready. So let's write a program. First of all, we have to include a library. So there is a library reg51.h. So hash include reg51.h, and then we will type void main. Okay. So let's write a complete infinite loop at the end so that our program remains here. Okay, now let's compile it. Let's see whether we are going right or not. Okay, there are 0 errors. That's fine. Okay, now you will be questioning or thinking why we have used this while loop, infinite while loop. It is written there because if we don't put a while loop, our program will run only. But we want our embedded application to run continuously, right? So in order to do that, we have to put the entire code in an infinite loop, so that infinite loop keeps running every time, right? Okay, now let's do some stuff. We can simply put like let's send some data to port, right, at an interval of some amount. Okay, so let's say p1 equals to uh, 0x00, and then okay, we have to call delay. Now there is no delay function within this defined within this compiler id, so we have to write our own function for that delay. So let's say we are writing a function to provide a delay of 1 millisecond. So we have learned in our earlier video how to compute the delay of 1 second if we are writing in assembly language programming, right? But in a case of C language, we don't have that liberty, and because we can't exactly know how that particular code is being transferred into the assembly language program, so we cannot compute the delay like we did in assembly language. Okay, so in this case, we will apply different trick. So we will compute a delay, and then we will see that amount of delay on a CRO, or you can say on some function generator, right? So let's instead of this p1, let's do 01, and we will create a function here void delay, and it will be getting some values. So unsigned int I. Okay, or I should say the ms, like millisecond and value in the milliseconds. Okay, so how we will do provide a delay? We will run the while for loop. Okay, so let's say for I like I equals to 0 to, okay, we have to provide this int I comma j, and for I equals to 0, I is less than ms and I plus plus. So this part will run for number of milliseconds for which we are providing the delay, and then the internal inner loop will provide the amount of delay for 1 second, for 1 millisecond. So for j equals to 0 to j is less than, now it has to be some number. Okay, let's make it unsigned so that our number goes from 0 to 65535, right? So let's make it some 1000, because right now we don't know uh, for 1 millisecond for how much amount of for how many times this inner loop should work. Okay, yeah. So we will do nothing, it will just simply keep on running. Okay, so it will run for 1000 times this inner loop, and then this outer loop will run for this many of times. So if we have provide ms2, so this inner loop will run two times. Okay, so from here we can came to know, okay, how much amount of delay we will be getting so if this loop runs for 1000 times. Okay, so we can pass here 2, no 1, so that inner loop runs for once only. Okay, okay, so let's compile it. Okay, there are no errors, so we'll go to the debugging mode. Right, in the debugging mode we'll go to view, right, and then we'll try to add that one, logic analyzer. Okay, logic analyzer has been added. We have seen this logic, how to configure this logic analyzer in our earlier video. We'll go to setup, and here we will type p1, right, because we are transferring our data at p1, and we'll change its maximum value to 0x01, right? Okay, then close it, because we are sending our data to p1 only. Save it. Now let's run it. Okay, so here we are getting these pulses because this p1 is going 1 and 0 simultaneously. So we'll check how much amount of delay we are getting for one amount. Okay, so this from here to here is being provided from first delay. Okay, so here we see it is getting a delta of around 5.5 milliseconds. Okay, so now it seems like we have to half it. So this entire loop is providing the delay of 5.5 milliseconds. So let's make it to 500. Okay, instead 490 because it was 5.5. Okay, let's compile it again, and then let's debug it again. Yeah, and let's run it. Stop. Okay, zoom in. Let's see how much amount of delay we are getting from here to here. Now it is 2.962 milliseconds. Okay, now it is, we just go half, so it has to be by 5. Yes. It has to be around less than 200. Okay, 190. Save it, compile, and then running it again. Okay, so zoom in. Okay, now it is 1.5 million. Okay, let's reduce it further. Now this is 1.5 millisecond corresponding to our crystal oscillator frequency of 12 megahertz, because we have used 12 megahertz. So if you change this frequency, then this will not be true for your application. Okay, so let's make it 100 and 20 only. Okay, not, yeah, 120. Let's see if it works. So this is for once only, because once we know the exact number for which it will give the correct amount of delay, we can use that particular code again and again. So here, yes, it is now 1.003 seconds. So that's perfect. Okay, so now we are getting at this value, we are getting a delay of 1 millisecond right now, right? So let's say I want to run it for 500 times, then we'll get a delay of 500 milliseconds. So it will not be exactly 500 milliseconds, it will be a slightly up and down. So let's compile it, okay, and then see it again. Okay, so let's run it. Okay, we have to zoom out a little. Okay, there, and then there. Okay, it is near about 0.491 seconds, that is around 500 milliseconds, because that much amount of delay is increases because earlier this outer loop was running for one. So when we are running this outer loop for 500 times, so delay introduced by this amount is also included in it, but approximately it is fine. So this is how we can do simple programming in C language, and it is very basic. Like you just use functions and normal C data types and C syntaxes. So that is pretty easy, right? The only thing is additional syntaxes are like this P1. So this P1 is specifically designed for 8051 microcontroller, right? Because in 8051 we can access the any port of the microcontroller by just typing their port number like P1, P2, P3. Okay, so uh, now here comes to our first question, and after that we'll do a major application. We'll go writing a program for a new application. So our question is, listen it very carefully. What is the jump range of SJMP command? Remember in our earlier last time video we talked about SJMP command, short jump. So in that short jump, what is the jump range? That means for how many locations from your current location we can go with the help of this SJMP command. Okay. So whoever will give the first answer, he will win 20 rupees INR of this question. Okay. So now let's jump to our second topic, which we are going to cover that will while moving forward in the same series. Okay. So today's session was like related to embedded C and then its application with interfacing of LEDs. So that is very easy. So we are going to talk about interfacing of LED. Okay. So whenever we talk about some hardware interfacing, so general flow chart for hardware interfacing is like you should also remember it. First is go through the hardware specification, like how the what are the different specifications of that particular hardware, that means the current ratings, their pin configurations and all those things, and then create a circuit diagram, right? Circuit diagram means how you are going to interface that particular, or how you are going to connect that particular hardware uh, with your microcontroller, and then we write a program, and once the program is written, then you can go for the simulation. So these are the general technique, general flow chart for it, and then after simulation we go for the real hardware. So right now we don't have real hardware, but we will go up to, we'll follow all these steps, that is hardware specification, circuit diagram, writing a program, and then the simulation. Okay. So now when we coming to the hardware, so first is the LED. Okay. Dimpy Sharma has won, and we will provide her 20 rupees. Ayana. Okay. So when we are talking about this LED, so if we talk about the structure of the LED, it looks like something, or it is represented by something. There are two things, P and N junctions. So P junction is known generally written as positive, and the negative junction is written as negative. So if we talk about a general diagram to turn on this LED, some of you may think, okay, if we just connect this supply, it will turn on. Actually, it will blow up this LED. Why? Because LED stands for light emitting diode. So if we are making this light emitting diode in forward bias, it will offer a very negligible resistance, and a very high amount of current will flow through it, and it will burn it out. Okay, so the correct diagram of this LED is this one. So there is a LED, and along with this we connect a resistance which is known as the current limiting resistance. Okay, and this is the correct LED symbol. So here is R. So general range of R is, if you are using LED for normal application, it can go from 100 ohm to 1k. Okay, if it, because it will limit the amount of current, so the luminosity, that means how much LED is glowing, that will vary depending on this resistance. Okay, and it should be 5 volt. Okay, so this is the simple hardware specification of the LED and its circuit diagram. Now the question arises, how we are going to connect it with the microcontroller. So what happens, uh, here is our microcontroller pin. Here we have this 8051 pin. And this 8051 pin, let's say we are using port 1, so P1.0, and if we connect like this, and then, so remember I have told you, if we write 1 to any pin of this microcontroller, that signifies on its pin in real hardware plus 5 volt will appear, because this R8051 microcontroller runs in the range of 0 to 5 volt, and if we are writing 0, 0 volt will appear. So in order to turn this LED on, we have to provide it 1. If 1 is provided, LED will turn on, and if 0 is provided, LED will turn on. So if I can write it in the form of a truth table, so let's say, and this is the LED, so this is the pin number and the LED, right? So if pin number we are providing 1, LED will be on, and if we are providing 0, LED will be very simple. And now you know how to turn it on and off. So now we will be writing, we will be doing it a new way. Okay, so I hope you have gone through it. Okay, we'll going to the new. So now our requirement is, we have 8 LEDs from V1.0 to P1.7. Okay, 8 LEDs are connected like this. Okay, now we want to turn on alternate blinking. So what do I mean by alternate blinking? That means if this is on, the next one should off, then the next one to it should on. Okay, so that is known as the alternate blinking of LEDs. Now how can we do that? So let's think about from the register pin. Okay, pins register. So this is our port 1. So this is pin 0, 1, 2, 3, 4, 5, 6, and then 7. Now this specify the content of the pin, right? Now if I write 1 0 1 0 1 0 1 0, that means the pin, the LED which is connected to pin 0, that will become that will become off and the next pin will become on. Similarly, the next pin will become off, then LED connected to pin number 3 will turn on. Okay, so this is way LEDs will be glowing alternative, and the corresponding hex code will be 0x, I think A. So it's A and it's 1010. So 0xa. Now we want to turn because we want to blink it, so the LEDs which are turning on right now, those should be turned off. So the next instruction could be like this one. So this data set or this value will become 0x55. Okay, so now if we don't provide any delay in between, it will be like it will on and off, and we won't be able to see. So we will be providing a small amount of delay in between, and let's say delay of 500 milliseconds, so that for 500 milliseconds they remain on in one pattern, and then after 500 milliseconds they turn on in a different pattern. Okay, so now we will be writing a program for that. So let's jump to Keel, and we will create a new okay, let's copy it because let's copy this entire code because it will be handy. Otherwise we have to write this delay program again. So we'll create a new project, and then we'll write 5 underscore LED blinking demo, then project name LED blinking, and save it. We will select our microcontroller, that is 89C51. Okay, we will add new source file, add new item C, and then main.c, and then we will put the code here. Okay, so this is our delay code, that is fine. In the main code, so as we have seen, like we have to send like 0xAA for turning one LED at a time, and then 0x55. So we'll be doing exactly the same. So first we'll pass 0xAA, and after that 0x55, and at a delay amount of 500 milliseconds. So I think that's it. Now let's compile it. Okay, so 0 errors. We have used 12 megahertz crystal oscillator. Now because we will be now simulating this code entire circuit in Proteus, so what we'll do, we will have to create the hex file. So remember uh, in our first video or second video we have talked about it. After writing the code, the compiler generates the hex file which microcontroller understands, and then that hex file has to go into the flash memory of the microcontroller. Okay, so in order to generate the hex file, go to the components, target options, click here, and then okay, make it 12 megahertz, and go to the output and select this create hex file. Different options are available depending on what kind of drivers you have installed. So it will generate hex 80 format, target, and okay, and then compile it again. Now if you go into the same folder where this file we have created this file, so within that folder you will get this file .hex format. Like here it is, the hex file. So this is the file which we have to download on the real hardware. Okay, so there are different programmers through which we can do this kind of programming. Now first of all we'll check it, or we'll simulate it with the help of this Proteus. So let's create a new project within the Proteus. New one. So this project Proteus is a very versatile tool, and you can simulate different kind of projects on it, right? So let's create a project like LED demo. and we'll browse it to the new to the same location 8051. Okay, and then we'll go to next, next, and from this Proteus you can also create your own PCB finally as well. Okay, so now how to design it? So we have to create entire design here. So we'll go to P. Here we will select our microcontroller. So 89C51. We will get it here, and then just place it over here. So you will see everything is connected here. So right now we don't have to apply like crystal oscillator and power supply to it. That is directly inbuilt into it. So we just double click on it. Clock frequency is 12 megahertz and everything. Yeah. The only thing you have to do, you have to provide the path to the program file here, right? So we'll click on here, and then we'll go to the hex file which we generated, right? So it is like this Proteus gives you a feel like a real hardware. So we are now burning our hex file to the microcontroller by providing the path in software, obviously, and then open it. Okay, now we have to connect the LEDs. So we will select search for LED, and then we will use animated LED so that you can see it is changing its color. So it is blue and yellow. So okay, we will take only one kind of color. Let's make it green or yellow kind of thing. Yes, because yellow will be visible in online mode. So yellow color LED, and okay, and then select, right? So we have to connect it. In order to make the connection Proteus, just click on here and make the path traverse to the pin. Okay, if we double click here, we can make it hidden. Okay, so right now it is a simulation. If we do multiple LEDs, it is not going to burn the microcontroller. So we have to, let's connect 7 LEDs first. 1 2 3 4 5 6 7 and 8. Okay, on the LED, on all LEDs we will hide their description so that they take less space. Okay, so first time it becomes a tedious task, but if you create your own model once, that model can be used multiple times. Okay, so now our second LED is connected to pin number 2. Here is our third LED. From here we can change the size. So let's make it 10th snap size. Okay, so by doing this we can create connection very near and we can save the space. So it is more like a circuit designing. Okay. Uh, okay, now we'll select our resistors. So we'll click here and we will connect only one 1K register. Double click on the resistor and make it 1K. Okay, and then we can rotate it in vertical mode. Okay, so let's zoom out a little bit, and then we have to apply a ground there. So from here you can select ground Here it is. Now we'll connect all the LEDs to the same resistor. Just click on the node and then okay. So this diagram doesn't look so pretty. I am sure you can create by yourself as well. That will be in more good looking format. Okay, we have provided the files, address, and everything is fine. Let's go. Okay, so I hope you are able to visualize it. Here this red color shows power +1 and blue color shows it is ground. So if you can look at it carefully, all the blinking are alternatively, right? And similarly, if I zoom it a little bit, you can see that their color is changing. So this is like these LEDs are blinking at an alternate rate. So this is how we can write a simple program in embedded C on Keel software, and then we can simulate it on Proteus as well. Okay, so my next question is, and the final question for today is, what will be the machine cycle of 8051 microcontroller, right, if we have a crystal oscillator connected to it of 16 megahertz? So in other words, if we have connected a 16 megahertz crystal oscillator to the 8051 microcontroller, then what will be the machine cycle of 8051 microcontroller? So that is very easy question. I will be waiting for you to answer, and whoever will give the first correct answer to this question, he or she will be able to get the price of uh, price of 30 rupees. So I'm waiting. In the meantime, if anyone can have any questions or doubt, then you can ask by writing your questions in your chat box. Okay. Okay, so let's see. Okay, in the meantime, okay, so this was the program. Let's stop the simulation. Okay, so you can, I hope you have understand several things in today's video, and you will be using this I hope in this video. Okay, so you have learned several things in this video, and I hope you will be interesting in doing some different kind of good projects on it, and you will be connecting with us in the future as well. So Prince Sharma has given the right answer, 1.33 megahertz, because we discussed in our earlier class the machine cycle is equal to the frequency of the crystal oscillator divided by 12. Okay, so 30 rupees INR to Prince. Okay, so here we will close our today's online session. Finally, one more time, we provide online training, help in technical assignments. We also do industrial and freelance project based on data science, Python, machine learning, etc. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org. So that's it for this video. Thank you.